here at the Crescent Dunes Solar Energy project just outside Tonopah, Nevada.
This is really the first commercial scale facility utilizing this technology.
It's a solar power plant with the capability of storing energy in the form of molten salt.
Most conventional renewable energy projects, wind or solar, struggle with intermittency issues. So you get variations throughout the day. They're really looking for a nice, predictable, firm supply, and that's what we can provide.
One piece, which is 80% of the plant, is just a regular steam turbine conventional power plant. It's the 20% of this plant that is different than anything in the world.
We take molten salt in a tank and we pump it up to a tower. It's surrounded by a huge field of mirrors that we're standing in. Focuses the sun's energy at a heat exchanger that sits on top of the tall tower, and it heats that molten salt up from 500 degrees to over 1,000 degrees Fahrenheit. We then store that salt in a large tank, and then we can utilize it for energy generation when we need to. Storing the salt allows us to then move the electricity production around to meet the peak demand of the utility.
The tower behind me is surrounded by over 10,000 heliostats. The heliostats themselves are actually tracking mirrors that are computer controlled to track the sun to deliver the concentrated energy of the sun to the top of the tower. When the heliostats are first installed in the field, they're initialized and calibrated, and then they're turned over a computer. This computer directs the heliostats where to go, what to do. So essentially the algorithm knows exactly where the sun is and to direct and concentrate its energy onto the top of the tower. Right now we're standing inside of this massive stainless steel tank. The salt that will be in there will be at 1,050 degrees Fahrenheit in a molten state. When we want to make electricity, we'll start up our pumps and pump the hot salt through heat exchangers and superheaters and make the steam to be delivered to the steam turbine to make electricity and deliver to the utility grid. This material is a very high density material that gives it the properties to store an abundance of energy. It is very easy to handle and move, can be operated at high temperatures.
There's very little concern on hazardous chemicals and those kinds of things. Molten salt in this form is not a hazardous material. From an environmental standpoint, we utilize zero conventional fuels to generate electricity, so it's a zero emission facility for the life of the facility. If you look at whether or not solar could provide 100% of the electricity supply at some point in the future, the answer really is yes.